Hello students, today's agenda on this rainy day is to check homework. We'll learn trigonometric identities and you will be able to do 10.15. Today students will be able to work with trigonometric identities by simplifying. And if you already watched 10.14, that's great. You already know where these come from. We're going to be working with them. And proving some of them once again, but if you haven't, please do watch 10.14, or if you're familiar with the first identities, then there is you don't need to watch it, but I do recommend that you familiarize yourselves with these identities. Before we start, if you can work on this warm-up, take a couple of minutes, pause the video. It says which from the left column are equal to those in the right column, and now let's go ahead and match them. So sine of x will always match with the cosecant. Not with the secant, but with the cosecant. So this is going to be the reciprocal of 1 over cosecant. Cosine, 1 over cosine of x. The cosine goes out actually with the secant. Okay, so secant of x is equals to 1 over cosine of x. And tangent of x, that's easier to remember. Tangent and cotangent are reciprocal of each other. Okay, something else that I want you to understand, that if you create an equation with this, sine of x equals 1 over cosecant of x, you can also see that if you multiply, and this is by showing the work, okay, but you don't really have to do this step. I'll show you how to just reverse it. So this, if you're dividing, you multiply, this cancels and you get a 1 in here, equals, and here is the multiplication of what you just cancel, which is cosecant of x times sine of x. We divide by sine of x on both sides. This cancels, and now you have cosecant of x is equals to 1 divided by sine of x. Now I want you to notice that, again, since these are related, we can just swap their position and say that cosecant of x is equals to 1 over sine of x. See, you just switch that order, the sine in here and the cosecant in here. Okay, there. So it's the same if you say cosecant of x equals 1 divided by sine of x, or sine of x equals 1 over cosecant of x. Okay, and this is just showing the work, but just to understand that I can do the other ones without showing the work, I can say that secant of x is equal to 1 over cosine of x. Or I could also say that cosine, remember that you can just switch them without showing the work. It's going to come out, or you will show to come to this place right here. So I can just say cosine of x is equals to 1 divided by secant of x. And finally, the one that we have in here is tangent tangent of x equals 1 over cotangent. That's easy to remember, as I mentioned before, but we can also switch those. Okay, switch their position, and we can say then that cotangent of x is the reciprocal of, meaning 1 over, reciprocal is just 1 divided by that other one, tangent of x. And in here, my cheat sheet, I call it, I only have, let me see which ones do I have. I have secant, cosecant, and cotangent, so I have actually this 3. But again, you can arrive to the other one by canceling or just knowing that that's also true. Before we continue, let's define identity and trigonometric identity. So an identity is an equation that is true no matter what values are chosen. And I know that this is very simple, but that's so that we can really understand what it means. So these don't look exactly the same, but we can see that, oh, x plus 2x is 3x. So yeah, it makes sense. And when you simplify it, it does come to 3x equals 3x. And that's what we're going to be doing with trigonometric identities. But I want you to see that in here, it doesn't matter what value you put for x, you will always get a true statement on both sides. Because let's say that you choose 5. 3 times 5 is going to be 15 on one side. Right? 3 times 5 equals 15. What about on the other side? Well, if x is 5, you're going to have 5 plus 2 times 5. This is multiplication. You can put a parenthesis as well. According to PEMDAS, I do the multiplication first and just bring down the 5. 2 times 5 is 10. But when I add 5 plus 10, that's 15. So yeah, you get the same thing on both sides. That's what an identity is. Okay? If I choose, let's say 100, 3 times 100 on one side, the other one is 100 for x, 2 times 100, 3 times 100 is 300 on this side. On the other one, you get 100 plus 2 times 100 is 200. I add those. 100 plus 200 is 300 on one side, and I already had 300 on the other one. So yeah, they are the same. Or again, if you just simplify, you just bring down the 3x. And here, x plus 2x is 3x. So we have exactly the same thing on both sides. Okay, that's what an identity is. You get the same on both. Okay, now trigonometric identities is just an identity, but with trigonometric functions. And those will be sine of theta, cosine of theta. In here, I decided to change it again. You can change it, but you have to keep it consistent. And so you can use theta, beta, x, a, or any other variable, alpha. So again, just keep it consistent. Let's start with some examples. It says, prove the following equations by simplifying. And my first recommendation that I have for you is to start working on the bigger parts. And the second recommendation is that you start changing things to sine and cosine. Okay, that won't always work, but for the most part it will. And so in here, what I can do is, another thing that I recommend is that you know the rules of fractions, because those are going to be very helpful in here. In here, it says that you're multiplying sine of x times tangent of x, and you're dividing that by cosine of x. And so this is just extra information about fractions. Sine of x, tangent of x divided by cosine of x is the same as saying sine of x. In multiplication, I can just leave the denominator with one of the parts in the numerator. Okay, that's, for example, if I have sine of x, I can divide it as sine of x over cosine of x times tangent of x. Okay, but if it was an addition, and let me do it with a different color. If it was an addition, sine of x plus tangent of x, and we're going to use this, but we're not going to use this one. Just important to understand that. And you're dividing by cosine of x, then because of the addition, that means that the cosine has to be with both. It's a common denominator for both, and so that will be sine of x divided by cosine of x plus tangent of x divided by cosine of x. And we're not going to use this one in here because we don't have an addition in here. It's just some information that you will need and that will be handy. It will come handy, in the future. Okay. Okay, so knowing that information, I'm going to separate this, leaving the cosine with the sine. Okay, so I'm going to rewrite this as sine of x over cosine of x times, that means times if there is nothing in there, tangent of x equals sine square of x divided by cosine square of x. To our handy dandy cheat sheet. From 10.14, we proved this one. Tangent of theta equals sine of theta over cosine of theta. Remember that just because we're using x in here, we're going to substitute tangent of x with sine of x over cosine of x. And just bring everything else down. Okay. And the other thing that we learned in fractions is that when you have a multiplication, we just multiply across. So sine of x times sine of x will be sine square of x divided by cosine of x times cosine of x is cosine square of x, which is equals to sine square of x divided by cosine square of x. And as you can see, this proves that they are true because you have exactly the same on both the left and the right of the equal sign. And let's do another one, and it says sine of x times cotangent of x equals cosine of x. First, you have to try different ones that will go to make sure that they are the right one. Sometimes it takes a couple of tries. So again, I see that this is sine, cosine, so I'll work with changing cotangent. And so the rest I just bring down the same way. So sine of x, cotangent of x, I have here cotangent of theta is equals to 1 over tangent of theta, but I don't see anything in here that is related to that. And I also have that cotangent of theta is equals to cosine of theta over sine of theta. So let's go with that one. And again, you can try this one and you might get to this eventually, but you will have to do several substitutions. But let's have this one. Let's use this one right here. So it's going to be times cosine of x. We're going to keep it consistent, okay? Over sine of x equals cosine of x. Remember that this is like having it over 1. And in fractions again, you cancel whatever in multiplication we have kind of like in diagonal form, okay? This cancels, and now you end up cosine of x times 1 is just cosine of x equals cosine of x. So there you have it. They are equal to each other. So now you prove them to be true. Again, if you notice, we are using knowledge from before, so that algebra and also the number sense of fractions will come out handy. So it's important that we review those, but we're going to be kind of refreshing them in here, okay? Okay, number 3 says tangent of x times cosine square of x equals sine of x, and I can see here, times cosine of x. Okay, so let's see if I can fit it all. There you go. So in here, what I'm going to do is, again, try to leave it in terms of cosine and sine. So what am I going to try to replace? And that can be your beginning. Again, you might have to try it once again. But in here, for tangent, we have two that are related. Remember that this is also the same because we can switch them as we saw in the warm-up. You have that, and it will be tangent of theta equals 1 over cotangent of theta. Or you might want to use this one, which is directly to sine of theta over cosine of theta. That's what I'm going to use, which is sine, but not of theta. It's going to be of x over cosine of x. Bring down the rest of it, which is cosine square of x equals sine of x times cosine of x. In here, I can cancel this, but notice how in here I have a square. That means that I have two of this, cosine of x times cosine of x. So I can cancel one of them with this one in here. And so I'm going to be left with 1 cosine of x, okay? Then I rewrite it, so it's sine of x times cosine of x equals sine of x times cosine of x. And there you have it. They are equal. That's that means that they are proved to be true, a true identity. Okay, and I'm going to give you more examples now with the Pythagorean identities, which is this right here. This is the main one. The other ones come or derive from that. And you have 4 other ones that derive from these ones themselves. But what I want you to know is that I'm going to be creating more videos related to this topic. I'll do small videos with 2 more examples, and then you decide if you want to watch them or not, and that way you can get more and more practice. Okay, so if you want to subscribe, and that way you can get notified when there are new videos. Okay, so it says prove the following equations by using the Pythagorean identities, and what we're going to be using is the main one that came from a combination of both the Pythagorean theorem and the unit circle. So that's where this one came from. So we will be using that one. That's what we're going to start with, so that we get to that point. Okay, and so it says cosine squared of theta, cosine square of theta, plus sine square of theta, plus sine square of theta equals 1. Okay, again, we proved this one with the unit circle and Pythagorean theorem in 10.14. And so if you notice in here, we want to derive to 1 minus cosine square of theta. So that's easy. All I have to do is subtract cosine square of theta from both sides. This cancels. And now you have sine square of theta equals 1 minus cosine square of theta. Now the only difference in here is that I'm using theta in here, but what are they showing us? It doesn't matter if you replace, but you have to replace both. So it's going to be actually sine square of x equals 1 minus cosine square of x. And you can replace this from the very beginning or at the end, it doesn't matter. Maybe at the beginning will have been better. And so it proves that it's correct. Okay, for number 2, it says 1 plus cotangent square of x equals cosecant square of x, which is this one right here. But how does it derive from this one? Again, so it's cosine square of, I'm going to put x instead of theta, but remember that if you change it for 1, you're going to change it for all of them. Sine square of x equals 1. How do we get from here to that? And so in here, what I want you to understand is that to get to cotangent, okay, you either have to have 1 over tangent, or in here cotangent is cosine over sine. So let's try that, and that's what I would recommend. Either divide the whole thing, and we have to do every single term, divide by the same, and that means that you keep the equality, the equation balanced. Okay, so let's try, since it's cotangent, that's what we need, right? Then let's divide by sine. And since it's square, we have to divide by sine squared of x. And we will do that for all of them. Sine squared of x and sine square of x. We're dividing every single term by sine square of x. And you might want to say, why, if this is not square, why are we squaring it in here? Well, just because this is square, we're using the square in here for this part too, okay? But as long as you keep it consistent, that's okay. Okay, so cosine square of x divided by sine square of x is this right here, cosine divided by sine. That means that I can substitute it or replace it with cotangent square of x. Okay, for the next one, it's sine square of x divided by sine square of x. Anything divided by itself is always 1. And 1 divided by sine square of x, well, what do we have? 1 divided by sine. 1 divided by sine square of x. Then that means that we can substitute with cosecant square of x. And that's how we get to that. Okay, so just check, what do I need to get a cotangent oh, I need to divide cosine by sine, and that's when you start trying. If it works and you get to what they're asking you to prove, then that means that you got it. But if not, then you might want to try something different. Number 3, they're asking us to prove sine square of x minus cosine square of x equals 1 minus 2 cosine square of x. And so again, we have to start from our first proof of the Pythagorean identity, which is cosine. But you know what? Since I have sine square of x here first, you can just switch the order of this one and you will continue to have the same identity. Okay, so let me switch those. Sine square of x plus cosine square of x equals 1. Okay, you are able to switch the order of those because addition is commutative. And so I have to get from here to this. Okay, and so in here I start analyzing and I notice that on the right they're subtracting 2 cosine square of x. On this side they're subtracting instead of adding, subtracting cosine square of x. So what if I just subtract 2 cosine square of x from this side and I do it from the other side as well? So in here I can just rewrite it as 1 minus 2 cosine square of x, which is what I already have in here. In here, remember that if there is no coefficient, it's like there is a 1 in there. I bring down the sine square of x, and then 1 minus 2 is negative 1, but we don't really need to put it as it wasn't in here as well. So cosine square of x, and there you have it. You have what they ask you to prove. So in here we just brought this down because they're not like terms, but in here we just subtracted the coefficients basically, and 1 minus 2 is negative 1. And just bring that down. So that's it for the examples for 10.15, but I'm going to be doing more videos so that you get more familiar with identities, only 1 or 2 examples in each video. So the more that you see of them, I think this will get easier and easier. If you would like to see them, don't forget to give us a thumbs up, subscribe so you can get notified. Click on the bell and you get the notification. Around here is the playlist for this entire unit, and you will find the next video somewhere around here. Subscribe here and have fun.